collaboration takes place. We're actually able to the architect's able to throw up a design, the engineers be able to come up with a tentative structure, you're able to test the structure, you're able to, subcontractors are able to add their various elements to it, the lift and the stairwells, and the fire people can do their work to make sure that it's evacuable. And everyone's working on the same file format, so they're able to transfer and translate things. We're not quite, don't think we're quite there yet. But anyhow, this is sort of the minimum standard set by government procurement work. And then level 3 of this is this fully working. And we're using a single shared project model held in a common data environment, and all parties can access certain aspects of that model, maybe not all of the model. And this is sort of the target date is passed already. And it's been part of the strategy for the last decade or so. So we haven't actually achieved it. And I think a lot of it is some of these issues about sharing, the intellectual property, seem really hard to get working. How do I, you have a constantly evolving computer model. People are adding into it. How does my contribution get registered, get valued in an easy to access way? How is it listed? Where is it being documented? Other than my timesheet, where does it show up in the model, what I've actually done? And if I do something that forces somebody else to redo their work, who pays for that? That's additional work for somebody else who didn't actually anticipate it. So it still comes down, sharing is tough, everyone knows that. So anyhow, the hope is that the PAS, the standards will continue to evolve, and I'm keeping track on it. It's an interesting document to follow its development. Right, I'm going to skip over levels of information, levels of detail. I'll skip over this. Mention this briefly. So what this shows is I will talk about this because I did mention at the very beginning of the talk this idea behind obtaining full value from your BIM model. Everyone's working hard on all these contributions. You're building this fabulous device in your computer, this fabulous synthetic world in your computer, and it'd be better to make sense out of it, better to squeeze value out of it. So this figure starts at the brief stage. So this is the phasing of the project according to the REBA plan of works. And the idea behind it is this value grows, the bulk of the material grows, and as does its value, and that this value is maintained through the in-use through the buildings in use. So that you can start doing kind of cyclical economy things on it. You can make use of it for dismembering, for doing full calculations about the carbon footprint and about the waste generated by the building and how the waste is handled and managed, and about the effluents coming out of it and the cleaning process. So all of a sudden you're able to integrate this in-use model into a larger urban sort of management plan. How much water does it require? How much cooling? How much energy will it require if we retrofit air conditioning systems because of global warming? So the models themselves, there's this hope that the models themselves could be useful in a changing economy or changing climate. That's the idea behind it. Indeed, this life cycle analysis is becoming ever more popular. We've had a few students who've done their dissertations on it as well. Integrating LCA with BIM. It is quite nice. I mean, it's a bit of a pipe dream to be able to do it. And if you think about it, you'd have to have the whole. You'd have to have quite a few assets online in order to make any kind of meaningful kind of contribution. Right, Open BIM. Just to mention the open software, there's a movement in place called the open software movement, I guess. And it started at MIT with the Linux organization, which actually have funded one of my projects this year. Yeah, Linux, they produced it happened, Linux came about, they wanted to kind of stand up to Microsoft and the domination of these big, so a bunch of hackers got together, they set up a lab, they got contributions from different people, and they set up an open system. So they designed they designed an operating system which is used frequently. They designed word processing. Come on in, Murat. Bit late. It's okay. It's good to see. So this open software movement really took hold, and now there's some Linux systems are used everywhere, and you don't pay for the software itself, but you pay for the engineering, the configuring. It's actually quite a big business, you know. And it's used in servers and back office stuff. And in BIM, they wanted to do something similar. They wanted to create an open BIM system, BIM being a essentially a CAD/CAM system for the building trade. And it's a building smart data model. It complies with the international standards, the ISOs. Anyhow, it's just I think important to mention that we're not entirely reliant on these big behemoth companies, AutoCAD and so forth, in order to produce in order to engage with the BIM world.
But can I ask, Autodesk have a lot of products, like they have Revit, they have all. I've never heard of any open source ones.
Yeah, there is one. There's an open source program. Yeah, it's called Building Smart Data Model, using Building Smart Data. Open BIM. I think it's called Open BIM.
And it has things like Revit's top software.
Yeah, it has it might be a bit clunky. It might feel a bit
not as user friendly.
Not as user friendly, but you know, AutoCAD or Revit costs a lot. I mean, we're lucky we have the site license for it, but if you're not, you know, if you're an architect or an engineer working on your own. So there is a parallel activity going on to produce an open system. Right, just talk a little bit about the additional PASs, 1192.6. This is for health and safety information in BIM, so you can store that information there. 1192.7, construction production. This is all working towards the 5D BIM. So the standards are struggling to keep up with the evolutions in the technology. So the technologists got their head around it. It's just the adoption system is really quite sluggish, and that's because of the general difficulty in sharing information. I'm going to skip over the uni class. I'll do a little bit of a case. Actually, I'm kind of finishing. I'll just talk a little bit about some of these unified systems. So buildings, I mentioned, are ever more modified. And I came across one case in London, I think it's called Old Street. It's a part of London that is rapidly becoming the center of the sort of Silicon Valley of London, where all the fintech companies are. And I visited a site there, and they were complaining about the systems, the window systems that were being installed in the building. It was a retrofitted building. They'd extended it out. They extended the slab out, and they were fitting these panels, these, they weren't cassettes, they were cladding of some sort. Anyhow, this guy was launching cassettes, so they would put the whole side, each flat would have this was divided up. In fact, each section between these columns would have a single cassette that would be launched into place. And it was a real slick method. You know, they were cladding the building just really quickly. And I've left some YouTube links which shows how it worked. Yeah, they were bringing them up in these, I think they were bringing, these are lifts right here. They were bringing them up in these lifts, and then they were able to put them into place without a crane. Nice, it was very cleverly done. This I mentioned, this drawing I've talked about before. This is integrating the facade model into the shared architectural modeling. And then I just wanted to show you some of the complexity. This is when they were this is the final bit. This is in this building we're in right now, and this is the stairwell that comes up from the quadrangle. And the Abercrombie building is on the right, and the new JHB building where we're in right now is on the left. And this bit right there, they just didn't do it on a computer. I mean, you could see them out there with a measuring tape. You know, this is a very awkward angles, and they were worried about people hitting their heads on this corner right here, and getting the height right, getting actually the proportions right. Whatever fancy software they had, when it came right down to it, it was some guy with a tape measure figuring, you know, how long could this be, and they were sketching and drawing it out. So I included this just to show that even the best software, there's a certain point where you just have to get your sketchbook out, get your tape measure, and do it that way. I did visit a facade manufacturer and show how they were making these things. And this was state-of-the-art kind of lean manufacturing. The material came in over here. There was an NC machine. You can see just bits of it over there. And the operator, there were hardly anyone working here. Basically, there was an operator that was moving and loading the machinery. Once he loaded it, it cut it to the right size and angle. It labeled it so they know where it was. And then they brought it over to this area to assemble it. This is for a high-rise in Old Street. This is the building that I visited. And these were these cladding that they were doing, but curtain walling, I think they called it. And it was all made out of straight stock aluminum extrusions that had to be colored. They ordered it, and this poor guy, I felt really bad for him. They were trying to do it lean construction, so they were ordering just what they needed. And the manufacturing, they were ordering it a gray number 832 or something like that. They had a very specific gray color. But halfway through the production, they finished out the material that they had, and they made a new batch. The aluminum extrusion company produced a new batch, and they colored it with the same color, gray, whatever it was, and they installed it. But when you stood at the bottom, you could see that there was a color difference. There was a color change, and you wouldn't have seen it if you barely would have seen it if you matched them up together. And of course, they didn't have any left. They were all shipping it out, so they didn't have anything to compare it to. So they put up 3 or 4 stories of this slightly different gray color. Had to take it all down, go back to and of course they cut it. It was a complete disaster. But anyhow, I think that there was a lesson actually. This guy was extremely good at lean manufacturing, but it doesn't necessarily work very well in the construction industry. I'll talk a little bit about value management and sort of this. I mean, we're still in awe of the construction of the Shard. This is a photograph I took when it was still being assembled. There was a temporary crane here. They hadn't finished it. There's a bit that goes on afterwards. And so we visited quite a bit during the construction. We had a student who was actually working there who got us in. And it's just marveling at the level of perfection, the level of engineering, the technology they use. Arup did a series of videos showing the construction, and I strongly urge you to go take a look. I won't dwell on it too much. But the whole project was driven by this Italian. Well, it was driven by a British property developer called Irving Sellar, who died just recently, a few years ago. But he started out working in the market, selling stuff. You know, he started out with nothing. And the whole project wouldn't have gotten, and he speculatively bought this piece of property. The whole project wouldn't have succeeded if it hadn't been for Renzo Piano coming up on like a back of an envelope kind of thing. Here's a great design, you'll love it. But they made it work commercially by really clever engineering, by making the floor plates really narrow where they could be, by squeezing in extra floors high up, by replacing volume at height with a bigger structure underneath it, so they were able to actually produce a commercially realistic model. And there are other things, you know, they started building up before they had completed the foundations. So they were still digging down on a top-down construction while they were building the frame. And they were, you know, they timed it so that the weight of the structure itself wouldn't exceed the temporary foundations that they were installing. So they kept on building down and down on the same rate that they were going up and up. So I think there's 5 levels or something underneath this building. And it was built at the same time, so they had a contemporaneous upward and downward build in this particular thing. The lifts were amazing because it was designed after the World Trade Centers in New York were blown up. And so the lifts had to be kind of fireproof. You know, in a tall building like that, you just can't really expect to evacuate at height. So they had these semi-autonomous roofs, and they didn't want to put, because of the awkward shape of the building, they didn't want to put external lifts. So they used the working lifts during the construction, so they'd have to cap it off. So actually the lift manufacturer came up with a new design of lifts that could be moved up as the building was constructed. So a lot of really clever, technology. It's a composite building. The top bit is steel where you don't need such a big floor plate. The concrete, where you need a lot of soundproofing, and then the steel in the bottom bit where you can have thin plates. And they managed to squeeze it, I don't know, 3 extra floors for the same amount of height. And that was all it needed to change the business model. Okay, I'm going to skip over this last stuff. I'll leave it, I've talked a little bit about when it's being used, so I don't really need to go into that. But anyhow, I just wanted to mention a few things. Programs, which is what we've been learning up until now, there's some future to having them computerized. And everything is, or much of this industry is driven by this REBA plan of work. So we've repeated this stages and phases of construction. We've talked a little bit about publicly procured projects and how they're kind of driving the industry forward in terms of BIM. And we've talked a little bit about this sort of digital plan of works, the idea that you have a building now, not only the design of it, but the construction on a computer. And it's all made possible by this 4D BIM set of technology. Anyhow, thank you very much for your attention. We can chat for a little bit afterwards.